Question 10, vertical projectile motion. Stone A is thrown vertically upwards with a speed of 10 meters per second from the edge of a roof of a 40-meter high building. As shown in the diagram, ignore the effect of a friction. Take the ground as reference. So now they're talking about ball A that was projected vertically upwards. So define the term free fall. So free fall is a motion. Here we're talking about a motion during which the only force acting on an object is the gravitational force. So let's not waste time on that one. 10.2, calculate the maximum height above the ground reached by stone A. So since stone A was projected upwards, obviously it's going to reach the maximum height. So when it reaches the maximum height, the velocity up there is 0. So let's say 10.1, or so 10.2. So we're going to say we are looking for the height. So you can say Vf squared is equals to Vi squared plus 2a change in y. So remember, we're using y because it's vertical projectile. It's vertical. So Vf, that's when it reached the maximum height. So the velocity up there is 0. Then it's equals to initial velocity. Here we're going to choose the direction. So since the ball is going up, or the stone is going up, so I'm going to choose up or upwards as positive. So that is my direction. So it means this one's going to be positive 10 squared plus 2. So since we chose up as positive, it means the gravitational acceleration is going to be negative 9.8, then change in y. So here, this is 0 is equals to 10 squared is 100, then minus 2 times 9, negative 9.8 is 19.6, change in y. So here I'm going to take 19.6 to the other side. So I'm going to have 19.6 change in y is equals to 100. And then divide by 19.6. Divide by 19.6. So change in y is equals to 5.10 meters. So here we found the height reached by stone A from the top of a building. Now what about the height from the ground? So the height from the ground is going to be change in y is equals to the height of a building. It was 40, so it's 40 plus 5.10. So that's going to give us 45.10 meters. So that is the maximum height above the ground. Now the second question. Write down the magnitude and direction of the acceleration of stone A at this maximum height. So acceleration at the maximum height, 10.3. Acceleration at the maximum height is 9.8 meters per second squared. So the direction of gravitational acceleration is always downwards. So it doesn't matter where the ball is going, the direction is always downwards. Remember that. Now, stone B is dropped from the rest, from the edge of a building, of a roof, X seconds after stone A was thrown upwards. Stone A passes stone B when the two stones are 29.74 meters above the ground. Calculate the value of X. So now what's going to happen? Let's open a new page. So now we're going to talk about 10.4. So in this question, we want to know the value of X because that's when stone B was projected. So now the roof, I mean the building, it is 40 meters tall. So it means that's when stone A and stone B, that's where they met. So we're going to say, since we chose up as positive, our direction is up as positive, remember? Upwards as positive. So it means we're going to take the building as negative 40 because that is initial, and the ball after it reached the maximum height, it was coming back down. So we take it as initial, so it's going to be negative 40, then plus, they said they met here 29.74 meters. So that's when they met. So now what are we going to have here? We're going to have negative 10.26 meters. So it means that is stone A there. So let's talk about stone A now. So for stone A, you are going to have height change in y is equals to vi change in t plus 1/2 a change in t squared. So once they talk about two stones or two objects, this is the only formula that you are going to need. So change in y now, we're talking about negative 10.26 is equals to, initially it was 10, then the time, we don't know the time, then plus half. Since up is positive, it's negative 9.8, and then change in time squared. So now we're going to deal with the calculator. Obviously we're going to apply the quadratic formula. So here we're going to have negative 10.26 is equals to 10 change in t, then minus 19.6 change in t squared. So take this to the, I will take this to the other side. 19.6 change in t squared minus 10 change in t minus 10.26 is equals to 0. So here we're just going to apply the quadratic formula. So we're going to avoid, or we're going to ignore the negative one. So when we apply the quadratic formula, then the time is 2.79 seconds. That is stone A. Now we can move to stone B. Let's just divide here. Then for stone B, we have change in y is equals to vi change in t plus 1/2 a change in t squared. So we're going to use the same height or the same distance, negative 10.26. then it's equals to, initially stone B it was dropped, so since it was dropped is 0 plus 1 half negative 9.8, it's for up is positive, and then change in t squared. So since this one is 0, so we're going to have negative 10.26 is equals to negative 19.6 change in t squared. So we divide by negative 19.6 and then we take the square root. So the change in t is equals to 1,45 seconds. So since now we have this time for stone A and this time for stone B, so now we want to know when was stone B thrown or projected. So the value of x is equals to the time for stone A. Stone A, it was traveled or it traveled 2.79 seconds minus 1,45, and then this one is going to give us 1,34 seconds. It means that stone B, it was projected 1,34 seconds after stone A was projected. So that's how we approach this question. Now let's look at the next question.